Hello everybody, my name is Subhashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions and I welcome you all to this special webinar today. And today's topic is configuring and troubleshooting BGP and Cisco routers. We will see the BGP basics, what about the border gateway protocol of the Cisco, what are the salient features of this protocol and how to configure and troubleshoot it. So let's begin. So, in the introduction, we will discuss what is BGP. We'll cover the fundamentals of the BGP, including the configuration steps, how to configure it on the router, and how to troubleshoot, how to do the troubleshooting techniques in the BGP. So, BGP is a border gateway protocol, and it is a protocol used to exchange routing information or NLRI between autonomous systems on the internet. So it is the protocol that is chosen by the ISP. It is not the protocol that is used in the enterprise networks because in enterprise networks we do not have so much routes like you handle the lakhs of routes or NLRIs, the network advertisements in the ISP, but in enterprise network you do not have that much. So you have say handful of thousands of routes. So there you use the protocols like EIGRP and OSPF. But in internet backbone, in ISP network, you use the BGP. It allows for routing decisions based on paths. So it's a path vector routing protocol and it takes the routing decision according to different metrics and network policies and rule sets also, making it crucial for the stability and reliability of internet routing. Now, in the key concepts, we include the autonomous systems that is there in the EIGRP as well as in the OSPF that is there in the BGP also. The routes, prefixes or the NLRI, path attributes and BGP sessions. So an AS is a collection of IP networks and routers. It's a logical area under the control of a single organization. Now it represents a common routing policy to the internet. Now you have to understand these terms and it's very essential for effective BGP management. So BGP versus other routing protocol. If you compare the BGP with other routing protocol, why is BGP so dominant? So BGP is a path vector routing protocol. Means it is neither distance vector nor it is advanced distance vector like the EIGRP or it is not the link state either. BGP is a path vector routing protocol which ensures loop-free interdomain routing and it is dependent on certain attributes. We call it the path attribute. While other protocols like OSPF and EIGRP are used for intra-domain routing, means between the enterprises, but it is between the ISP, you use the protocols like border gateway protocol. BGP is more complex definitely due to policies and path selection procedure and offering more control over routing decisions compared to these interior gateway protocols. So how to configure the BGP? Basic configurations include that you have to enable the BGP on the router. Definitely you need to enable it like the EIGRP or RAPE or the OSPF. Then you have to define the local AS number. That is very important. You can configure the iBGP, that is the internal BGP. Then all the routers will reside in the same AS, or you can have the external BGP, that is the eBGP, like you are having an AS1 and in the other organization that is having say AS2. So that is the eBGP you can configure. So you have to configure or define the local AS number and establish BGP neighbors. Then commands include router BGP and then the AS number in the config mode. Then neighbor IP address and the remote AS or the AS number. So this is the full line of the command. And set up relevant network statements to advertise routes. So you have to advertise the specific route and remember that you have to advertise here the specific subnet mask also. If you do not specify the specific route, then it will not happen. Like if you are having an IP address, say 1112, so in that case, you have to specify 1.1.0.0 that way. If you specify 1.1.0.0 means if you do not specify 1.1.0.0 and if you specify 1.0, then it will not take the correct network address. So you have to be very specific in case of BGP. In case of OSPF or EIGRP, we keep only the network address, the classical address there or classless. But in case of BGP, you have to specify the mask and the network fully. Then what about the route policies and filters? Like route policies in BGP are crucial for controlling traffic flow, and we use the route maps there heavily in the BGP, and it ensures that only desired routes are propagated. So here the ACL, simple ACL is not used. We use more advanced route filtering like route maps. And filters can be created using route maps prefix list and access list to some extent to manage which routes are accepted or advertised between peers. So you can use a prefix list or access list to actually define the network, define the LAN, but to implement it to the other neighbors, you have to use the route maps. In the neighbor configuration, to configure the neighbors in BGP, you specify the BGP neighbor statements definitely, which define the IP address of the BGP peer and the remote autonomous system. Remote AS means it can be the same AS if it is in the IBGP, or it can be the different AS. Now, this is achieved using the command neighbor with the IP address of the neighbor and the remote AS and the AS number of the remote AS. It is essential to ensure that both the routers are reachable, because reachability it is very important in case of BGP. If the next hop is not reachable, if the next hop neighbor is not reachable, then no relationship can be formed in the BGP. That is very important. And firewall settings, you have to allow for BGP communication. So next hop reachability, that is a great condition for the BGP. Then in the BGP troubleshooting, the common BGP issues include unreachable neighbors that I was talking about. If the neighbor is not reachable, if you cannot ping the address of the neighbor, it can be loopback, it can be, say, the Ethernet port, but if you cannot ping it, then definitely there is no neighbor relationship. Incorrect AS configurations. Now you are having, say, two routers or three routers in incorrect AS. You are configuring IBGP and you are giving wrong AS number. You are configuring EBGP and you are giving wrong AS number. It will not do. And route filtering mistakes. That is also very crucial, because route filtering is used to actually minimize the number of update packets in the BGP. And if you cannot do it properly, then it will get a lot of broadcast traffic. Now, solutions often involve varying network connectivity, checking configuration for accuracy, and ensuring appropriate route policies. So you have to verify the network connectivity if it is reachable, and then you have to check the configuration for the accuracy, and you have to ensure appropriate route policies are applied. It is very general. Using ping and traceroute can help diagnose connectivity issues definitely, because these are the layer 3 diagnostic tools, as we know that it is used to solve the network issues. So you have to definitely use these tools to identify or diagnose the connectivity issues. You can use the debug commands also. Debugging is a very important part for BGP, and it can be facilitated by commands such as debug IP BGP. It will show you in real time what about the packets that is flowing between the routers in BGP, and debug IP BGP updates. So it will show you the update packets of the BGP. And these commands enable real-time monitoring of BGP operations, and it will help identify problems with route advertisements and neighbor states. And caution is advised, because as extensive debugging can impact router performance, because it is CPU intensive. So if you are doing the debug command, then the router is performing high on CPU utilization. So definitely you should not run debug commands unnecessarily. Then you have to verify the BGP neighbors. Verifying the state of BGP neighbors is essential for connection troubleshooting. So if the connection is stable, you have to verify. Then commands like show IPBGP summary and show IPBGP neighbors provide insights into the status and performance of BGP peers. So if the BGP peers is there, you have to make sure that whatever the state the BGP peers are in, and you have to verify it within these commands, including state, established, idle that I was talking about, and the number of prefixes received. So if the number of prefixes received is mismatched, in that case, the neighbor relationship is troublesome. So you have to make sure that the number of prefix received that is also, it is not giving you some sort of trouble. And also the BGP states, the open state, established, idle, so open connect, these are different states there. So you have to make sure that you have to just inquire about the states there. Now, what are the BGP best practices? To optimize BGP performance, you have to implement the route summarization to reduce the size of the BGP table, as in the case of EIGRP or WSWAP also. You have to do the summarization or aggregation. Apply route reflection or route reflector to minimize the number of BGP sessions. In the IBGP session, in the IBGP, you have two options. Either you have to do the full mesh connectivity, or you have to use a route reflector to minimize the number of BGP sessions or the TCP sessions and utilize configurations for scaling large networks. So you can use a route reflector for a small network comparatively, and if the network is a bigger network, then you have to do a configuration. Now, properly tuning timers can also improve the convergence times. Security also is a consideration for BGP because BGP is vulnerable to various attacks such as prefix hijacking and route leaks. So this is prone to attacks also. So mitigation strategies include implementing filters to restrict route advertisement, then using TTL security mechanisms, that is time to live, and establishing session authentication with MD5 password to secure BGP session against the unauthorized access. So you have to make sure that you include the password there also so that the unauthorized access doesn't happen. Then the scalability and design is also a consideration because scalability in BGP design can be achieved through route aggregation or route summarization, employing route reflectors, and utilizing a hierarchical design for larger networks. So if you are supporting a large number of NLRIs, then you have to do the route aggregation. This approach allows for efficient management of routing information, and it facilitates growth without extensive reconfiguration. You do not have to configure again and again. So we can conclude that in summary, understanding the BGP configuration, troubleshooting, and best practices, they're all critical for maintaining the robust and secure routing policy. So if you are implementing the BGP in the service provider backbone network, so you have to consider all these points together. And effective management of BGP can enhance network performance and reliability also, while mitigating risk associated with potential vulnerability. So there should be some risk, but definitely you have to make sure that you implement the security policies thoroughly to actually mitigate this task. So this is about the brief overview of the BGP basics and troubleshooting and configuration. And also now I can take you to the console, and here I am running a GNS3 because BGP is not running perfectly in the Cisco packet tracer. It is very limited there. So you just switch on these routers. They're switched on and you can see the interface are green. And now this interfaces, this is fast Ethernet port to fast Ethernet. You can have the serial or any other port. Now you can configure the IBGP or EBGP. Will do some very basic configuration here. So the putty is being connected. There you are, the routers are booting. And you have to just go to the interface, say 0 by 0, and give the IP 11001. And you can configure a loopback also. And the R2, see this R2 console. So 11002 in the first Ethernet, and in the loop back 2001, and you can give any mask because it supports the classes also, but I'm giving the default for now. And now what to do, you can go to R1 also, you exit and come back to the config mode, and now router space BGP and then the AS number, say the AS number is 1. Now here you have to configure the neighbors, you have to configure the neighbor. Then if you give question mark, it will ask for the neighbor address, and now the neighbor address is 11002, and then the remote AS. If you configure the EBGP, in that case you will give the autonomous system different, say autonomous system 2, but I am here considering that two routers are in the same AS, so it is the IBGP, internal BGP. So here I'm using the same AS, so the AS number is 1. Now this is done in the R2. Similarly, do the same thing, router BGP and AS number 1, and then the neighbor statement, neighbor is 11.0.0.1, and the remote AS is also 1. So now this neighbor is up. You can see that immediately we get the response from the BGP that the remote neighbor is up. And now you can advertise the networks as well using the network statement. The network, and that is the serial or the Ethernet network. Here we do not have the serial, so you advertise the network 11000, the exact network, and you have to configure this way. Mask, you have to write it mask, and it's 255000. And also you can advertise the loopback. This is the 1.0.0.0, and the mask is 5500. Similarly, in R2 also you advertise networks. That is the Ethernet port network that we have in 11000, and you advertise again the loopback. So I've advertised all these things, and now if we see the IP route, so IP route, and you can see that we have got the IP routes there, and it is showing that 1.0.0.0, and look at the AD value, this is 200 in the IPGP, and you can see that we have got the route 1000 via 11001. The loopback is advertised here, and also you can go to the R1, show IP route, and you can also see that 2.0, that is the loopback of the R2, that is also advertised here. So we have got the BGP relation, and B, this is denoted as the code. You can see that B is for indeed the BGP. So you have got the BGP peers here. Now if you do the command show IP BGP, there's a question mark, and see you have got a lot of commands there. So you just say BGP and neighbors. You will see the neighbor in detail. BGP version is 4. By default, remote router ID is 2001 because we haven't set any BGP router ID. But it is recommended to set a BGP router ID in the config mode, just like in the case of OSPF. But if you do not set this, then it will set the remote ID as a loopback interface. That is why it's 2001. Neighbor sessions 1 is active. It is showing the detailed output of all the packets also, like open, notification, updates, keep alive, refresh. So it's giving a lot of information of the neighbors, and it is more than any routing protocol. It is more than the OSPF or EIGRP, because I've already told you it is the backbone routing protocol. It's used in the ISP backbone, so it is a huge protocol. So it has a lot of things. So you can get a lot of informations here. How many packets are sent, receive, everything. Again, if you give show IP, BGP, say you can have other things also. You do not configure the address families here, but if you configure, I have already shown you the neighbors, or if you configure the paths, or let me show you the summary. That will do. Show IPBGP summary, and here you will get the summary output because BGP root identifier is 1001, that is a loopback IP of this router, and you can see that it's using the version 4. You can see the neighbor is 11002, the version is 4. AS number, this is message received and message sent. So how many packets have been received and sent? So everything you can say you have received here in the show IP BGP summary. We haven't set up any path attributes here, so it will not give a proper information of the paths or any sort of like that. Also, you have different options like this VPN, V4, this routes. This is for the address family. Like in the EIGRP or OSPF, also BGP supports the V6 as well as the V4. By default, it is IPv4, but you can have the IPv6 also. So there is an option that is used in case of the say MPLS, like you can have this VPN V4 route there. So you have a lot of information, a lot of options there in the BGP because it is used widely in the routing backbone, the ISP routing backbone. So it has a lot more features that you can get in that you cannot get in other routing protocols. And these features, everything is not available in the Cisco packet tracer. You should have the advanced simulators like GNSC or even G, and we are running the like the here we are running 72000 series router real iOS, and you can get this all these features there. So you have seen that BGP is very complex and it is more advanced routing protocol that we have today. And it is very essential to learn the BGP for your Cisco, maybe the CCNP Enterprise, the NRC paper, the Advanced Routing Security and Services paper there. We have a lot of things in the NRC regarding the BGP also in the enterprise core, that is the core paper in the CCNP and CCI level. There also you have the basics of BGP and some path attributes also, but it is in the great detail in NRC mainly. And also in case of CCNA, we do not have the BGP directly nowadays. We had the BGP, the external BGP, but nowadays we do not have in 200301. But still, I recommend you that you have some basic knowledge of the BGP to be very helpful for your certification goals and for your career paths as well. Now, this BGP will stay for a long time, even after the automation came, because BGP is a more preferred protocol, and only one other protocol is there, that is ISIS, that is like the BGP. It is also used, but BGP is used more than the ISIS protocol. So these things you have to study for your career and for your certification goals. It's very important points for the BGP that we have discussed today, the theoretically, and also I've shown you the basic BGP configuration. And there are a lot of configurations in the BGP, more advanced configurations like route reflector, path selection, different things that I will show you later. So that is it about today about the basic BGP and troubleshooting and configuring. I hope that you have learned a lot about this BGP configuration, and I hope that you'll be able to configure the BGP and also you'll be able to troubleshoot it. I thank you all for joining and watching this webinar once again. So that is all I have for today about the BGP basics. I'll come with some new topic next time. Till then, bye and keep studying.